It's my pleasure today to introduce a panel on entities, relationships, and semantics, the state of structured search. And it's particularly a pleasure because I get to introduce a panel of four folks who are some of the leaders in this area and folks that I've had the chance to work with personally. So first I'd like to introduce the panel, and then I'm going to ask them to answer particular questions suited to their areas, then ask questions of one another, and then actually give a chance to folks here to ask particular questions. So first, to introduce the panel, we have Andrew Hogue, who is a senior staff engineer and engineering manager at Google New York. In fact, he was my manager not that long ago. And he's worked on a wide array of products in structured search, including Google Squared, Google Goggles, and a variety of local and product search products as well. Next, we have Breck Baldwin, who is one of the co-founders of Alias-i, a local company in Williamsburg that you may be familiar with because of the popular LinkPipe natural language processing package that's in very wide use. Then we have Evan Sandhaus, who is the semantic technologist at the New York Times Research and Development Group. And he leads a lot of the linked data initiatives, also curates the New York Times annotated corpus, which if you haven't used, I highly recommend for both academic and industry work. And finally, we have Wlodek Zadrozny, who is a researcher and manager at IBM Research. And he's worked on what I hope you all know is the Deep QA or Watson product that recently defeated Jeopardy champions in quite a feat of machine versus human. So with that, what I'd like to do is ask each of them particular questions about their areas. So why don't we start with Andrew? You've worked on projects like Google Squared that focus on entities rather than documents in the information-seeking process. What have you learned from users, and what do you see as the main quality and interface challenges in this space, including, for example, having a microphone to answer the question?
That is an interface challenge.
Until we have a wireless mic, you could use the podium.
Okay. This also lets me cheat off of your question here. As Daniel mentioned, I've done a lot of work around using structured data in search. I worked on Google Squared. I also work on things like question answering on Google.com, a lot of named entity extraction, local search, things like that. One of the biggest challenges I've found is that, obviously extraction in structured data is never perfect, right? Even if you have a highly curated database like Freebase, you have a lot of data that really isn't good. The coverage isn't good. You might know about 20 of the dog breeds in the world, but you don't know about the other 200. You might know about some of the properties of things like chemical elements, but you won't actually know about all of the properties of all the elements. So if you try to build a search engine on top of this kind of incomplete database, users start to rely on it more and more and more. And all of a sudden, they go off a cliff, and they find out that there isn't data there, and they get very, very frustrated. One particular place we ran into this was when we were trying to build user models, trying to understand what people like. We were trying to say, for Google+, for instance, understand, do you actually like something in the real world? Do you like Tom Hanks? Do you like Big? The real thing in the real world, not just some web page or some string. So this is great because it's unambiguous. You know exactly what it is that the person likes. But if the universe isn't complete, then all of a sudden people start typing in longer tail entities or people that we don't know about yet, and they get very, very frustrated because we can't represent them in our system. So this has been one of the big frustrations, and one of the solutions that we've come up with, one is to get a bigger database, obviously, but the other big solution is to fall back gracefully when you don't know about things. So we found the best solution here is hybrid systems, that some of which are structured and know about a real core database that we know a lot of information about. We have pictures of things and so on. And then if you don't know those things, you have to be able to gracefully fall back to a world where you just know about strings. So I guess that's about it. That's my 4 minutes.
Cool. Yeah. No, it's fascinating to see that recall and coverage problems, which are the converse of the precision problems that are typically the challenge in information retrieval, seem to be what dominate in this space. Got my cliff notes here. So Breck, you work in natural language processing, and certainly natural language processing has captured the public imagination. I mean, all of us who grew up on science fiction films expect to be able to to talk with our machines, and I think it's safe to say that most of our experience in the real world seems to lag behind that vision. So you have one of the most popular NLP packages. I'm curious, what advice can you give to people who are actually building systems and setting expectations for how they're going to interact through NLP?
That's an excellent question, and it's something I've actually blogged about. And so if this gets recorded, go hunt down my blog post from March 8th of 2009. One of the most important lessons you can walk away from this panel, I think, is a better understanding of what you, the user or the customer, can bring to the game when you're trying to build natural language processing systems. And there's just a couple of simple things you can do that really up the likelihood of success. Because the biggest problem with fielding natural language systems and talking to management and talking to customers is the natural language processing system that's in their heads. This is the world's best natural language processing system, bar none. It is so easy for human beings to do natural language that they underestimate the difficulties of having a computer do it. And the only way they start to get a feeling for that is through 3 very simple steps. First is they need to take some data and annotate it, mark it up for what they expect the computer program to do. Go through, do 10 examples, hand it around to everybody that's got a share of whatever the problem is, and say, is this what you want the computer to do? That will disambiguate things beautifully. It will force a lot of fights earlier when someone says, no, I just want sentiment over Twitter, and then you actually have to look at tweets and say, is this positive, negative, or neutral, or are there other categories I care about? All of a sudden, those conversations become much more substantial and much more focused, and the likelihood of success goes up tremendously. That is the number one best thing you can do. The next thing you can do is always build simple prototypes, if at all possible, that just connect the bits. Because in enterprise deployments, you tend to have somebody says, yeah, you can connect the databases, no problem, I got all this information here and there and everywhere. Just getting the information flow for a simple, stupid implementation will help disambiguate things as well. And this is just sort of standard software engineering practice, but it comes up all the time. Oh, I can't get you that data. You're going to have to find another way to get it, stuff like that. And the last thing, which is super duper important, is an evaluation metric that maps onto whatever your business need is. And that business need can be, I want to win a bake-off, a government bake-off for named entity extraction, or that can be, I want to take over the world, or index information by concept or named entity. But you need to have an evaluation metric that supports that so that your developers and everybody can watch that number as it improves. It should support the business that's driving the creation of this NLP system more substantially. So that's it. There's a blog post that goes through that in more detail if you want.
Thanks, Breck. So, So, Evan, the semantic web. You have to pick on every myth that causes people problems. So it's perhaps hasn't been around quite as long as HAL and sort of visions of talking to computers, but certainly it's either been praised as kind of the logical evolution of the web. I can't remember if it's currently considered Web 3.0 or someone else has taken that moniker, but it's also been dismissed by many as a pipe dream, and you're leading the open data strategy, the linked data strategy for the New York Times. So how do we distinguish myth from reality? And what are the practical things we can do here and now with the technology that's available?
An excellent question. So I think that the semantic web as it exists today is rightfully viewed by some as a very complex implementation of some very simple good ideas. And I think there is a reward to really learning the stack and seeing what the full semantic web technology stack can do for you. But I think most organizations are going to find a greater reward by getting their toe wet with a couple of those ideas. And the ideas that I've looked at at the New York Times Company come down in 2 areas. They come in the area of linked data, like you mentioned, and in the area of semantic markup. And in the remaining 3 minutes of my response, I'm going to try to explain what I mean by those 2 terms. So the New York Times, like libraries around the world, catalogs its content. We've done this since 1851. Every article that we write gets associated with people, places, organizations, and descriptors like terrorism, Iraq war, things of that sort, from a controlled vocabulary of people, places, and organizations and descriptors. And so we have strong identifiers tied to all of our documents, but what we don't have is context for understanding what those identifiers mean. For instance, we don't have a database that says Barack Obama is president of the United States. We don't have a database that says, Kansas City has this latitude and longitude. However, there are databases around the web that have this information. And our linked data work has been to take the identifiers that we use internally for our own data and line them up with external data resources so we can use that external data to reason about to add new context to our understanding of our data. So we can answer questions like, what are all the articles that appeared on page A1, column 1 that are about a president of the United States in the last 30 years? We didn't have the context before we started doing this linked data work to answer that question. Similarly, what are all the articles that occurred last week within 30 miles of Park Slope, Brooklyn? Again, with additional metadata, we can answer those questions. And the trick is figuring out how your internal database identifiers align with external database identifiers, and we've been doing that work for the last couple of years. The other thing that I think is really helpful is semantic markup, and semantic markup is the idea of taking a plain Jane HTML document that you serve on the web and indicating that certain parts of that document have a significant meaning. For instance, a news article is going to have an HTML element that contains the headline, and it's nice to indicate that that's what that means, because when you get indexed, maybe you want that to be the thing that shows up as the link to the article. So realizing this is an important thing for us to be focused on, the Times has partnered with an industry digital standards body called the International Press Telecommunications Council to develop a data model of how publishers can use for publishers to use to embed publishing metadata into HTML documents. That data model is called RNews, and it shares a goal with the work that schema.org has been doing, which is a collaboration between Google, Microsoft, and Yahoo. And yesterday I was in Mountain View because we just announced that schema.org has incorporated the RNews vocabulary into that standard. So we're really pleased to see that. We're really pleased as a standards body and as individual publishers to see the strong move towards semantic markup of news. So I think semantic markup and linked data are two critical things that are really powerful that come out of the semantic web that can do a lot for news publishers today.
Thanks, and I just want to express personal appreciation for the data that the New York Times, the Guardian here also have been sharing, because it's been making life much better for lots of folks well outside the news space. To introduce our fourth panelist, the very nice hard coffee helps. So Wlodek, earlier this year, IBM really stunned the world by defeating Jeopardy's top human champions. So my question is really the generalization of that, which is how does this apply to domains other than winning on Jeopardy, which, as I understand it, does cap out at maybe about $100,000 prizes? So what can you tell us about what's possible today, and what are the open problems in the space?
Thank you. Okay, so let me start with sort of reminding everybody, how Watson worked, or explaining it to people who don't know. Basically, what's happening with Watson is the following: that when a question comes, it gets analyzed, and after that, a search is performed that produces hundreds of possible candidates. What's happening next in the pipeline is that each of these candidates is again analyzed against the corpus of data, and together with the question terms, we are trying to detect relations. That is, to understand whether the entities that appear, say, in a passage of text are in the relationship that the question is asking about. And this happens with, these hundreds and possibly thousands of different candidates. It's done all in parallel. And at the end of this process, we have results of multiple scorers deciding, whether, this particular aspect of the relationships, like, how often do they appear together, okay? Do they have the same logical form, okay? Do they have the same modifiers? Is it positive or negative, okay? All that kind of stuff is put together with different scores, and at the end we produce a score for each of these possible candidate answers, and then we rank them. So the operation is massively parallel. It involves tons of different textual data, but also, some data in the RDF form or database data. And we also deliver the confidences. So that is important when you play Jeopardy, because you get penalized if your answers are wrong. Okay, so that's what's happening, and the question now is, where else this kind of methodology can be applicable. So this is, of course, in some sense a speculation, since we don't have, other proof points. But we believe, for instance, that medical domains would be one such application. So actually IBM announced a few weeks ago a collaboration with WellPoint about trying to apply Watson technology to understand the potentials of treatments to make the patient's life better, and also to assist with diagnosis. So that's sort of a short answer. The medical domain, maybe some other domains could also be applicable, and we can speculate which ones that would be. But I want to say that what's behind Watson's success is essentially three things, which are sort of the data that we use, and I will go into that in detail. The methodology, which is more or less along the lines that that Breck mentioned, that is, testing often, don't expect perfection and so on and so forth, and and the science of putting it all together. Now, since this is a data conference, let me say a few words about data. So what we have is three important things, which is question-answer sets, which we get, from the historic archives of Jeopardy, and that allows us to test the system on a relatively large number of question-answer pairs. The total archive set, I think, is about 200,000 question-answer pairs, and about 100,000 of these is post-1984. We had access to textual sources, and that included, a bunch of dictionaries, encyclopedias, including Wikipedia, some RDF data, DBpedia. And finally, the third element of it is test data. We tested extensively. We have run probably about 7,000 experiments, of which some of hundreds of experiments with really large data sets, large collections of questions. And these experiments generated between, let's say, 20 megabytes to probably about 700 megabytes of data per experiment. We analyzed this data. We done a lot of error analysis. We tried to see what works, what doesn't. The data was also used, in the machine learning fashion to improve the performance of the system. So these three items, that is question-answer sets, so the test data, on which you test the performance, the final performance of the system, the sources, that is the data from which you can prepare your collections that you're going to use, and finally, the test data from the actual work of the system, the trace data. This is what's behind the success. And I think if you have these three elements, given that the methodology is free, the science have been done, if you have the data, you should be able to apply it in other domains. So medical is one such a domain. Some people believe that also legal could be such domain. Other people, mentioned education. We are now, I am part of the team that's pursuing sort of the medical stuff, and that's where we want to go in the near future.
Thanks. It's very encouraging, because I think of these as fields where right now so much knowledge is locked up in very inefficient ways in professionals. The idea of democratizing that through any sort of interfaces, but particularly natural language ones, is very, very appealing. So what I'd like to now turn over is to a crosstalk session where panelists get to ask each other. And I think I'm going to invert the mapping a bit and say, does somebody have a question they'd like to ask Andrew? And
I have a question. Oh. It's on. It's on. Oh, hey, there we go. I actually have a question for both Andrew and Breck. And the question is that I work in the New York Times Research and Development Lab, and our mandate is to sort of is to forecast out how trends are going to play out over time. And one of the trends that I care a lot about, and I'm sure other folks in this room are interested too, is sort of the trend lines around natural language processing. And the trajectory of NLP seems to be that certain things eventually graduate into a level of reliability where they can be incorporated into production systems. And I'd like both of your perspectives on the sort of technologies that you think will graduate into reliable productive systems over, say, the next decade from where we are today.
Rochambeau.
3.
All right.
So yeah, it's an interesting question. I think the thing that I think most about these days is actually the question answering application, which I think we've talked a lot about today. We have a problem on Google where we're trying to surface answers to direct questions. People don't tend to talk to Google in natural language. We've trained you all too well to use keywords. So instead of saying something nice like, how tall is the Empire State Building, we get Empire State Building height. And this confuses us a lot sometimes. Things like Harvard College. It's kind of sometimes hard to tell that apart from LeBron James College. One of those is a legitimate search for an answer, and the other one is just a navigational query that's trying to find a particular homepage. So deep down underneath all of that is a lot of this natural language understanding that we're talking about here. We're seeing more and more that because we have so much data to bring to bear on the problem, we can start to apply more statistical methods to natural language that we haven't been able to before. Internally at Google, I'm starting to see this kind of breaking point where we might actually be able to get something back out of the system that's a lot more reliable by using all of that data to try to understand which situations we've got a good parse, which situations where we don't, and also kind of those in between areas where we need more information. So that's one of the areas, I guess.
It's an interesting question. I might have a problem. Well, I'll address it directly, which is I think classifiers and classification technologies are getting very robust and very good. And people can train their own classifiers for something like sentiment or topic identification and stuff like that. And that's something that a small shop can do without a lot of NLP talent hanging around if they can just sort of get a basic interface up. But I think the field in general, I think the real breakthroughs are going to be in highly customized systems, which is kind of contrary to what your point is, which is that, when can you go out and buy one of these things shrink-wrapped like a database and expect certain levels of performance? And I think the interesting levels of performance for natural language processing will be with highly customized models or scenarios like Watson, for instance, that is finely tuned to a domain and performs in ways that sort of bring a lot of value to whatever organization has decided to field the technology. And that's where the future lie in terms of, at least my efforts, is making it easier for people to customize those systems.
I actually want to ask Evan a question, which is to sort of flip this around, unless somebody wants to ask this for me, which is, in some ways, all of the emphasis here is on the query side of natural language, and yet it seems that all of your efforts really focus more on the document side. What do you see as any trade-offs, or why have you chosen your efforts in the way that you have?
So it's interesting. So much of current natural language processing with technologies like entity extraction are trying to sort of give you facets on documents that allow you to reason across documents at a more meta level. But a lot of the work going into those technologies is about perfecting them. And what we're able to do at the Times, because we have the luxury of handcrafted metadata for our articles, is ask ourselves the next question of what can you do next when you already have perfectly accurate metadata? Of course, we would like to, everybody wants more robust and more metadata, but the metadata that we do have is hand-checked. So the reason I'm looking at it from the document perspective and the sort of structured metadata perspective is that we're in a position to ask the questions that people who focus primarily on NLP won't be asking until their algorithms get to the quality of handcrafted metadata. And the irony of this is we feel like we're on the cutting edge until we look at library science. And they've been doing this for about 200 years. So there's a lot of lessons to be drawn from the library science community when it comes to dealing with high-quality structured metadata. So that's kind of why I approach it from the perspective I have.
And Wlodek, you have more to add.
Yes. So let me add my 3 cents to it. In Watson, we discovered that there is an alternative to high-quality hand-cured data. That is, what we did, for instance, is we augmented existing sources that we had, such as, say, encyclopedic entries or dictionaries, with data, with snippets of data gathered from the web. And while this data was very imperfect and occasionally very noisy, it had the advantage of often expressing expressing the same content, the same semantic idea in different terms with, different combination of modifiers, words, and so on and so forth. And we found that this substantially improves the performance. So I think that there is a balance between having, highly processed, curated data, and with, a lot of data that you can use properly if you have, probabilistic algorithms that allow you to get what you need from it.
I actually want to take it back to Andrew, because it seems that both of the Jeopardy domain and to some extent the domains that you've worked on at Google, I'd say qualify as open, at least in terms of their generality. And the pointed question would be, if NLP can win at Jeopardy, can we already have an NLP system for the open web, or where would it break down?
Yeah, that's actually that's a good question for Wlodek, I think. When are we going to get Watson for everyone else, I guess? Yeah, I mean, I think one of the, as I was mentioning before, one of the things about doing this kind of question answering for the open web and for the open query stream that we see at Google is just that we're not getting enough information from users. I wish people would ask full-formed questions of us. It's something like 30 to 1, keyword searches to real natural languages. Even with voice search, where you'd think people might be a little bit more comfortable saying something, who was that architect that designed that famous museum in Bilbao, Spain? Like a real question about what they actually want. They're still doing a keyword search. They're first going to search for Bilbao, and they're going to search for museum. They're going to kind of go through this sequence of keyword searches. Whereas I think in the Jeopardy domain, which is really interesting, is you get a lot more context. Jeopardy questions are very pointed. There's some tricks in there, I'm sure, that that don't exist in real life. But I think having additional information on the query side is incredibly valuable. So until you all start asking us real questions, I would say it's going to be harder for us to do that. I don't know if Wlodek has more to say about that.
Blame the user.
Yeah, blame the user. That's our mantra. Yeah.
I think it goes under the topic recognizing user intentions. I mean, we don't know what's behind the query, and as you said, I mean, in the Jeopardy domain, we know what's behind the query. We know that the answer is supposed to be unique. I mean, at least in most of the cases. In the medical domain, the situation is somewhat more complicated, so it's not just one question. Very often, it's a process of diagnosis. But I still believe that pretty much the same techniques can be applied, just iterated and provide good performance. When you go to a search engine and you have only 3 words, that's really tough.
I actually want to follow up on that. And anybody's free to answer this, but what's interesting about the Jeopardy scenario you just pointed out, there's a known answer. I think with the way many people use Google, they expect a known answer, and I'm not allowed to disclose the fraction of navigational queries, but plus it's out of date. But I think there's an interesting case where you're not sure if there's an answer. You mentioned working in the medical field, Wlodek, and obviously in Google, sometimes people look for things that don't exist. Dan Russell, runs a column which is right at the edge of that. How does that change the way that these systems would work if there may not be an answer? And your Evan seems to be chomping at the bit.
No. I don't have a good answer for this one. I'm ready for somebody to take it.
I'll take a stab at it, just because I think it's computationally interesting, which is a lot of computer science and natural language processing has been driven towards first best analysis, which is essentially saying there is a unique best answer. And what that does, there's a bunch of reasons for it, but a big reason for it implicitly is the efficiency of computation if you're only trying to find a single answer. Once you have to entertain multiple hypotheses and sort of have clouds of hypotheses that you're working with sort of ambiguous data with multiple annotations and trying to combine it in useful ways, the challenges are just overwhelming in terms of just fundamental data structures, presentation of results to users. It's a very, very tough area to say, I'm going to express an intent. I'm an autism researcher, and I want to know something about autism. I'm trying to do some work around autism. I don't know that there's an answer out there, but I need clues to point me in the right direction. It's a very difficult problem.
Yeah, I think one of the things that search engines, and this goes back obviously way before Google got right, is not trying to zero in on one answer, but presenting a set of documents, right? I mean, so if you have an unknown intent and you don't know if there's an answer, and you have the luxury of not zeroing in on a single answer, give people lots of answers, and it becomes a collaborative effort between the user and the search engine to try to refine that query and eventually get to the right answer. It's a lot more like browsing the shelves in a library and flipping through a book than it is, asking somebody and having to require a direct response right away with no kind of backup information. Am I allowed to ask a question now?
Absolutely.
Okay. So I had a question actually for Evan. There's definitely the spectrum, I guess, from completely automatic, extraction, labeling, things that we can do statistically and other things like that, all the way over to the other side to hand-curated, finely tuned, expert data. Oftentimes, tools that start off as kind of manual curation kind of slowly get more and more, kind of automated, and the computer helps more and more and more. Have you ever seen tools graduate to, in the other direction, to being more and more automatic? That, something that started off as kind of a tool to help your curators label documents and index them, eventually became so automated that you could take the human out of the loop? Or is there anything that you see on the horizon that could do that?
So I think the story about how we index documents speaks to this. The Times has traditionally, we continue to produce a print index for the reference library market. It is a big red book that I would not want to drop on my foot. And it is assembled manually by a team of library scientists every year. But we tag on the website as well, and we use a slightly different process for that because the New York Times Index, despite being a wonderful resource, operates on a different schedule than the website, and we need real-time metadata for our website because the tagging powers a lot of features on our site, like topic pages, email alerts, and things of that sort. And so what we use in that instance is we use a rule-based information extraction system that takes in the document and suggests to the producer of that document, the person who's taking it online, terms they may wish to associate with the document. And then they manually select the ones that are correct, and then the document goes out to the web. And then one of our two digital librarians, who are real heroes, so I'm going to say their names, Christy Riley and Jennifer Perucci, go through those documents, verify the producer's tags, and send out an email at the end of every day basically saying this looked good, this probably should have been tagged this, and we're going to add these new terms to our dictionary. So we sort of do a hybrid approach online. We do a semi-supervised automated system, but then once we have that metadata, we can start doing more automated things. Like the topic pages have a list of articles that's populated from an automated query. And sometimes we update those queries by hands, but we can start relying on that data to do automated things.
I'm actually a question open to anyone here, which is that evaluation is interesting, and you point out the sort of the quality issues. So I think people are pretty comfortable with evaluating the precision of any sort of automated tagging, but it's a lot harder to evaluate the coverage. Right? So for those not familiar, I mean, it's one thing to say, if I tag this document as being about big data, you could say yes or no, but you won't necessarily know that you forgot to include it or whether you chose the best tag. So I think all of you in some way or other are in spaces where this comes up. And what advice do you have, or secrets can you share about the way that you do this sort of evaluation?
I'm just going to have an answer that has a recall in it, and then we'll take that as... recall is really hard. I mean, so just to define for people, precision is accuracy, which means if you make a commitment, this is full of water, it will be full of water. You won't make many mistakes. Recall is that everything that's full of water, I will identify as full of water. And for me to do a very simple 100% recall system, I would say every container in here is full of water. I'd make a lot of mistakes. I'd be low precision because it'd be false positives. But that's what precision and recall is if you don't know. There's a very interesting space that I'm just going to throw out there, which is named entity extraction, which is finding person names and stuff like that in text, or gene names or whatever it might be. And high recall entity extraction is very hard to do. In fact, it's probably not been, you can't, the simple way to get 100% recall in documents is you basically say every possible subspan is a named entity, a person name. And that's obviously idiotic. And then, so you try to back off on that and say, okay, at what point can I get 99.99% recall, find all my entities, what's my precision, how many false positives am I getting? And it's a very tough place computationally. And, we're at 5% precision or something, as we try to do that kind of stuff. And in fact, I'd throw this out to the other panelists. We can have a little geek conversation here. You guys doing anything fun with recall and named entity extraction? And are you beating our numbers? Because I want to see a better system.
Anybody want to take that on? So in our last 5 minutes, I want to give everybody a chance to sort of give the audience something to take away in this space. So everybody, take a minute. What do you want people to remember?
We start from that end this time?
Sure.
I guess I would just repeat what I said before. That is, if you are looking for a system that can answer questions, you need certain types of data. That is, you need the data on which you're going to test the performance of the system. So this would be questions and answers. You need sources, and you will need to do some work to prepare these sources properly. And then you need to test and gather the data about your tests. So I think this is one thought that I would like to leave with the audience.
So the thought I'd like to leave the audience with is that over the last couple of years, we've been doing some very interesting things with our structured data, and it's convinced us that it's really valuable to get structured data out there as in as complete a fashion as possible. And that's the reason that we have been contributing to the standards effort, this RNews work that has been incorporated into schema.org. And we really the thing I like to leave folks with in this room is that if you work on a publishing website and you do have structured data that you would like to make more explicit, I strongly do encourage you to take a look at this. Take a look at this work. The websites you probably want to check out are rnews.org, schema.org, and if you have any questions, I'm evan@nytimes.com, and I'd be happy to help in any way that I can to help you understand how you might be able to get more of your structured data out there, because I think that's really going to be a game changer when a lot of publishers start having really good high-fidelity structured data available to the web.
So 3 points. 1, annotate your data before you undertake the task so you understand what the task is. And then the last point on that is have an evaluation metric that maps onto what you care about in the world so you know whether you're doing good or bad as you change the system. And the last point is if you want to play around with building these systems, LinkPipe's a free library you can use, so please use it. It's out there for people to play with.
Thanks. So I guess I'll just echo. I didn't get much chance to talk about this, but I'm also involved with Google's data markup. I'm involved with schema.org and Freebase and a lot of the other things. And so, as Evan said, share your data. I think that's one of the big takeaways for me, is that the more data that's out there and the more data that's marked up and reconciled with other databases, the more interesting things we can all do. It helps search. It helps people at the New York Times. It helps users. So I think get your data out there and don't be afraid to share it, because it's gonna be much better if you kind of let it free. and ask longer queries too. I guess that's my other takeaway.
So with that, I'd like to thank all of our panelists and thank you all for your time.